Today we're doing lesson 64, which is truly a shorter lesson. But before we get into that, I would like to discuss the common errors from Can You Do 62? Because there were a few things that I saw repeatedly that I think are worth addressing. So the first one is not a huge issue. It's just a little thing. But it's worth mentioning. If they ask you, like in a free response question, if they ask you to find your Z critical and show your work, they want you to draw the normal curve and like label all the things. But then somewhere it's really important that you make the statement of what your Z critical is. I did not mark anybody off on this question if you didn't do this, but many of you drew the right picture, and I know that you knew what your Z critical was. This is just one little element that, if you can remember, is best for you to do. Just somewhere clearly state my Z critical is 2.33. Many of you were getting 2.326 or something along those lines. I'm not sure if that's 100% right, but I know where you're getting this number from, and I'm okay with this number. But one thing that I want you to consider is that when you actually use your Z table, when you really go to find your critical value, your Z table doesn't give you 3 decimal places. Your Z table gives you 2. So I would keep in mind that when you give a Z critical from the table, just be aware that this is the number that the table would give you. This is the number that your calculator gives you. So be aware on that. Many of you guys know, because you've taken 1030 or I think that Bracken might have showed you in Honors Math 3. I'm not 100% sure. Many of you guys know that you can find these areas using your calculator. But if all you do is use your calculator, they don't even give you partial credit. They mark you all the way wrong. So I'm good if you use your calculator as long as you have all of the supporting work that goes with it. But if all you do is use your calculator, even when the answer is right, they will give you 0 credit. So 31, just a little correction. For 35B and 36B, one thing to keep in mind is that they are asking if a specific value is plausible. And in both cases, it is a P of 45. So they're specifically asking about one value. There were a handful of you that were making statements like, there are values less than 45, or there are values greater than 45. But in this specific case, they are only asking, is this number in your confidence interval? This number and only this number. Now, I understand why you're getting confused on that, because we had a problem about the percent of Americans that wanted to lose weight. And they were asking you about the claim, is it possible that more than half of Americans want to lose weight? This is a different situation. They're specifically asking you about a range of values. Is it possible that more than half? So we are saying things like, well, all values in our interval are greater than 50. But the reason we're doing that is because it matches the claim. And here, the claim is just one value. So all you're addressing is it in the interval or is it not in the interval? We're kind of okay there? If you've picked up your review, hopefully you can see, like, picked up off your desk and held it. It's long. It's 20 pages long. Because I'm wondering if part of the reason why we're not scoring as well as we should on our exams is because you are not being exposed to as many problems as you need to be exposed to. So I tried to give you plenty of opportunities in your review to practice making the distinction between when it's asking you about one plausible value or when it's asking you about a majority of people. Okay, the last correction that I wanted to make, well, maybe there's two, but this one is the most important one. So the teens that text with their friends every day. Some of you guys were making the statement that we were looking for P, which is the proportion of teens that reported texting with their friends every day. This would get you 0 credit. I want you to think about, take like 30 seconds to think about what could be the problem with what we've written here. About 10. Okay, so now I'm going to tell you the problem. It is the word reported. See if you can figure out why this statement is not true, that we're trying to estimate the proportion of teens that reported that they text with their friends every day. Give you about 20 seconds. About 10. So the issue here is that you're saying, you're using past tense, and you're saying we're 95% confident that this interval captures the proportions of teens that reported texting with their friends every day. Well, what that would mean is you talk to every single teen and have the true value of P. But the whole reason that we're estimating P is because it's impossible to get a hold of every single teen that exists. Do you guys get what I'm saying? We're not estimating the true amount that recorded. We're estimating the proportion of teens that would report or will report, not the amount that recorded, because that means you truly talked to every teen and know the proportion that reported. Does that make a little bit of sense? Are you sure? Okay, that's, for some reason, that's one issue that is important to the AP graders because it truly indicates whether or not you know what you're estimating. Most of the problems don't really give you the opportunity to confuse this. So this is really the only problem where you could have worded it wrong. So just be on the lookout for it as you work through your free response problems on your review. Then the last one that I wanted to mention, just kidding. There was no multiple choice on this? No? Okay, then we're good. What one was I thinking of then? You're turning in 63 today, right? No, it must have been 61. So I'm sure that the issue I'm thinking of will be in your review. So on 62, keep those things in mind. On 63, which you're turning in today, I'm just going to come around it like I did last time and check in with you and answer your questions personally. I find that to be much more effective than asking if you guys have any questions as a whole. So just know that if there's anything you need to clear up for 63, I'm happy to help you when I come to collect it. So that leaves us with two things to do today. We have lesson 64, part 1 and part 2. They're both math calculations. They're both solving equations, using algebra to solve equations. So hopefully this is a nice little detour for some of you guys. So the first thing that we're going to look at is the needed sample size for proportions. The needed sample size. So today's lesson is all about determining what sample size would we need for a specific margin of error. Because honestly, we want our margin of error to be as small as possible. We always want our error to be as small as possible. So this is the last 2 pages in your lesson. It's page 622. So where are you at? Okay, when planning a study, we may want to choose our sample size. So we might want to have control over how many people we sample. I'm just looking for my pen, as usual, because that's my whole life. So in planning a study, we may want to choose a sample size that allows us to estimate a population proportion within a given margin of error. So we may want to choose a sample size that allows us to have a desired margin of error, because we want our margin of error that is small as possible. One of the ways to decrease margin of error is to increase sample size. So you may want to write that down somewhere. If you want to decrease margin of error, that means that you need to increase sample size. Maybe need to is a strong statement, but this is one way to decrease margin of error. We're doing this because we are targeting a specific margin of error. Because the margin of error involves the sample proportion of successes, p hat, we must guess the value of p hat when choosing n. So I'll give you like 10 seconds to fill that in, and then I'll explain what they're saying there. Okay, so we want to take a sample. And when we take this sample, we're going to be calculating p hat. But in order to figure out what sample size we need, that calculation involves p hat. We don't have p hat yet. That's what we're trying to get. So what can we use for p hat? Well, we have a couple of options. Number one, use a guess for p hat based on a pilot survey or on previous p hats that were found in similar studies. So we either use a p hat from a pilot survey or we use a p hat from similar studies. The one that we use the most often, though, is called the conservative estimate. Oh, that's not how you spell conservative. That's a V. And the conservative estimate is a p hat of 50%. So either we are given a guess or an estimate for p hat to use, or we use p hat of 50%. The margin of error is largest when p hat is 0.50. So this guess is conservative in the sense that if the true p in our study comes out to be anything other than 0.50, our margin of error will be smaller than the minimum we found, which is good. So essentially what they're saying is that when we use the conservative estimate, it gives us the largest possible sample we would need. So no matter what we get for the true value, we're probably in a good place. They'll never ask you why you use P of 0.50. This is just there for those of you that wonder. Okay, so we use this information to solve our first example. PTC is a substance that has a strong bitter taste for some people and is tasteless for others. The ability to taste PTC is inherited, but some ethnicities are more likely to taste it than others. For example, about 75% of Italians can taste PTC. We don't know why this reaction occurs, but it is believed that it affects your food preferences. Have you guys done this in science before? So I have some PTC papers. While you're doing your lesson quiz, I'll run and get them and let you guys try it if you want to. So it's just a little slip of paper that you put on your tongue, and some people it tastes really gross, and other people it just tastes like paper. I only taste paper. So if you want to try it, I'll bring around a slip for you to actually see if you can taste it. You want to estimate the proportion of all Americans who can taste PTC. So we want to estimate the proportion of Americans who can taste it. They specifically tell us to use the 75% estimate in our calculation to find how large of a sample you must test in order to estimate P. We want to do this within 4% and have 90% confidence. So we want our margin of error to be within 4%, and we want to do this with 90% confidence. So for all problems that are like this, you use the following inequality. Your Z critical, because when we're working with P, we always use Z critical, times your standard error of P hat needs to be less than or equal to the margin of error that's desired. Hopefully you guys are recognizing that this is the formula or how you make margin of error. So we're saying we want this to make a margin of error that's a specific value. Okay, well, let's fill this in with what we know. So Z critical for 90%. We go to our pink table. The very bottom, because the very bottom is our standard normal critical value. 90% is 1645. So we go to the very bottom of the table. Oops, a daisy. The standard error of p hat is this big old fraction guy. And it's a little thing, but I'm making this radical so big so that it looks like my critical value is lined up with the numerator in my standard error. And I'll explain why that is after we fill it in. So we take the estimate that they gave us, so 0.75 times 1 minus that, so 0.25, all over n. And this guy is what we're looking for. We want that to be less than or equal to 0.04. We're making our margin of error less than or equal to 4%. Well, one thing that'll make this easier is if I extend this fraction line, because that's truly what I'm doing. I am multiplying these two things together. So what that would look like is 1.645 times the stuff in the numerator all over root n. So I'm going to split that out for us. This is the same thing as 1.645 times the root of 0.75 times 0.25. You can multiply that out if you want to. I usually just leave everything as is. This is all over root n. So I'm just rewriting this top fraction so that the root is in the top and the root is in the bottom. This needs to be less than or equal to 4%. And then in talking about solving, we have discussed how if you want to solve any equation that looks like this, you have a fraction equal to a number. You can just switch these two things. You just switch them. So you would end up multiplying both sides by root n and then dividing both sides by 0.04, which just ends up looking like these two things switched places. So now we have 1.645 times the root of 0.75 times 0.25 all over 4%. That's now got to be equal to, less than or equal to root n. Last step then is to get the root off of the n. The inverse of a root is a power, so we square both sides. So what I end up plugging into my calculator is a big fraction. I usually put the parenthesis, but you don't have to. So I would put parenthesis, green button, y equals. Choose option 1. 1.645, root button. 0.75 times 0.25. Arrow down. divide by 0.04, arrow over, end parenthesis, hit your squared button, which is kitty corner to the 7. This gives us 317.11. So I'm going to rewrite this so that n is on the left side now, because that's where I'm used to it being. So I have to have a sample size. Then make sure that your inequality is eating the same thing. So here the inequality is eating the n, so you have to keep it eating the n when you switch it. 317.11. Okay, well, what are we sampling? We are sampling Americans. We're trying to figure out how many Americans can taste PTC. Can we have 0.11 of an American? No. So our sample size needs to be greater than or equal to 318 Americans. You always round up. You always round up. Even if it's 317.02, you're still going to round up to 318. So if I want to be within 4% of the true proportion, I have to survey or sample at least 318 Americans. You're hanging in? Okay, let's try another one. They're all like this. You can solve every single one of these exactly the same way. Okay, so a company has received complaints about its customer service. The managers intend to hire a consultant to carry out a survey of customers. Before contacting the consultant, the company president wants some idea of the sample size she will be required to pay for. One value of interest is the proportion of customers who are satisfied with the company's customer service. She decides that she wants the estimate to be within 3 percentage points at a 95% confidence level. Okay, so we want to be within 3 percentage points, and they give you what decimal that matches. We use the 95% to find our critical value. And we're interested in P, the proportion that are satisfied with the company's customer service. So part A says determine the sample size needed. Okay, well, they give us no indication what we should use for P hat. In the previous problem, they told us use 0.75 as your estimate for P hat. Here, they don't tell us anything. They just say determine the sample size needed. So that means we use the conservative estimate. That means we can use the conservative estimate of 0.50. We set it up exactly the same. So the critical value for 95% confidence is 1.96. Our standard error is where the conservative value comes in. We are going to multiply 0.5 times 1 minus that, which is 0.5, all over root n. So in this case, we must use the conservative estimate because they don't give us the value to use. We want this to be less than or equal to 0.03. Then just like last time, I'm going to extend that fraction line and split the root. So I'm going to have 1.96, but I've done this so many times that I know what 0.5 times 0.5 is. So I usually write it as what it equals, which is 0.25. So when I use the conservative estimate, I always change 0.5 times 0.5 to 0.25. You don't have to do that. It just saves me a little bit of time. That's all over root n. We want that to be less than or equal to 3%. Then we do the switcheroo. And we get 1.96 times root 25 all over 3%. That's got to be less than or equal to root n. And then our last step, square both sides. Square both sides. Then, because I really hate hitting all the buttons, I usually just still the last thing that I plugged in, and I just go in and change everything. You can do whatever works best for you. So if I go in and just change things, that makes it a little bit faster for me. Hit enter. This time I get 1067.11. Is that what you guys get? Ugh. So n has got to be greater than or equal to 1067.11. So our final answer is that we need 1068 customers. We need 1,068 customers. Are you hanging in? Okay, so this was part A. Underneath that is part B. Part B says, in the company's prior year survey, 80% of the customers said that they were satisfied. Using this value as a guess for p hat, find the sample size needed for the same margin of error with the same level of confidence. So this time, they're saying use 80% as your p hat. The first one, they didn't tell us what to use. This second one, they're specifically saying use 80%. So it's going to look exactly the same except for what's under the root. 1.96 times the root of 0.80 times 1 minus that, 0.20, all over n. We want that to be less than or equal to 3%. So I want you to solve that out, and then I'll do one walkthrough and we'll check your answer. we only need about 30-ish seconds. About 10. Okay, I got 683 customers. Is that what you guys got? Yeah. So notice that if we have an estimate for P, our sample sizes that we need is less. Remember that when you use the conservative estimate, it gives you the largest possible sample you could need for that margin of error. So this should be bigger than this because this is the largest sample you would have to take. If you have an estimate, that makes it so that you can sample less people. So then part C says, what if the company's president demands 99% confidence instead of 95? Would this require a larger or smaller sample size, assuming everything else remains the same? And they want you to use a p hat of 0.80. I have found that the easiest, when they say explain your answer, the easiest way is to just solve it out and find out how many customers I would need. So the only thing that changes from this problem to this one is you need to change your critical value. So you guys try C. Change your critical value, and then we'll meet up at the end. Let's go about 30. About 10. So I got 1,180 customers, which means we would need a much larger sample if we increase our confidence level, which would make sense to me. If we want to be more confident, then it makes sense to me we would need to look at more customers, because the more information you have, the better. Okay, once you're done with this, get into Canvas and do the one question that's there. While you're doing that, I will go grab PTC paper for anybody that wants to try it.